Alright, so in the calculator, in the keyboard, there's a function button. You're going to scroll all the way down to the bottom of that. And there's something that says GCD. That's greatest common divisor. So when we're looking for the greatest common factor, we're dividing by something they have in common. It's the same thing. So if you use that, you can see what your GCF or GCD is. So like for the one I have, who has the GCF of 64 y to the third minus 56 y squared plus 88 y? These are bigger numbers, so maybe you don't know all the factors of those three. You could put that in. 64, 56, 88. You don't have to put the negatives. 64, 56, 88. And it's going to tell you the GCF for the GCD is 8, but it's not going to tell you what the variables are. So we know it has to be 8. You have to figure out what the variables are. So everyone look at your card, see if yours starts with an 8 at top, and then figure out what your variable GCF is. And if that's you, you would go next. And I have all the answers, so if you're not sure, I can check it also.
How did you do it?
Are you on the graphing or the simulation? Go to the graphing. And you type in these three numbers, 64, 56, 88. On Desmos. Go into the keyboard, go into functions, go all the way to the bottom, find GCD, type in all the numbers you have, and it'll tell you what that is. So everyone look at your card. If you have 8, then look at your variables, see what that GCF would be. Help each other. You may be sitting with it and you may not know. Also, let me make sure I passed out that one too. Who all has one that says 8 on it up top? What does yours say? Just the top. Would this be the GCF of this? Okay, so Nora, go ahead and read your card. Now we're looking for this GCF. Bless you. Numbers are 32, 8, and 4. If you're using Desmos, what is the GCF of that? 4. So everyone who has a 4, look at your card to see the variables if yours match. And I keep forgetting I need to double check to see if I have it. Would that be the GCF of this? 4x? Or do they have other things in common? Say that again. There's more than one variable. There's more than one x. So not 4x, but something else. Would y be squared for this one? No. there is a y in there. So someone who has a 4 and a y and there's an x, Tegan. Mm-hmm. Go ahead and read your card.
Who has the GCF of 12x to the power of 5 and y to the power of 3 minus 15x to the power of 8 and y to the power of 5.
Find that next GCF. Should probably put these out so I actually know what cards I have. What was the GCF number for that? 3. So everyone that has a 3, look at that card. See if your variables match. Who all has a 3? Does yours match? 3x to the third. Is that the highest amount of x's we can take out of that? No. Not yours. Who else has a 3? Tomas, what does your card say?
3.
What's the rest of it say?
5.
That is the correct answer. Go ahead and read that off. Tomas, go ahead and read that card off.
3 is 5.
The second part.
5, 6, x, 5, 5, 4, plus 14, x, y, 3, minus 8, x, 3, y, 2.
Someone find the next GCF. Okay, so 14 is the number. If you have 14, be looking at yours to see if your variables match. Help each other. Look at each other's. Read it. The third, okay. That works. So go ahead and read up your card. Who has that GCF? Yeah, okay. That one would just be x. So then, who has the GCF of x to the third y plus 9x squared y? Look at the people around you. Help those around you. Someone may have it and not realize it. Is there a number that they have in common? What do they have in common?
X squared.
Okay. So someone with an x squared.
X squared.
So someone that has that card, read that off. Read it.
X squared minus who had GCF of 8x to the third plus 4x squared is 12x.
So Aiden found that GCF. 4x. So that is, read that off.
We have the GCS of 40x squared minus 100xy minus 80y squared.
Okay.
It's 20. What is the GCF of 2x squared plus 8x?
It would be 2x. So whoever has that, you're up. It could also be me. It is definitely me. My bad. Alright, so 2x, who has the GCF of 10x cubed y squared minus 25x squared y to the third? I do not have that. Next one.
Would that be negative 25 or would it just be regular 25?
When you put it into decimals, just put it in as 25. Now, if you were writing it out, it would be minus inside the parentheses. So 5. Dylan?
Mine just says 2. And for the other one?
For which one?
The one that we did before.
The 20?
Yeah. Do you know where you did that? Or?
Oh, the 2x, no, that was mine.
Okay.
So someone that has 5, go for it.
Do you want me to read out the who has it?
Yeah.
Who has the GCF of 7x4 minus 35x3 minus 14x2?
It would be 7x squared, yep. Is that you? So whoever has that. There's only but so many left. It's not me.
Actually, 12x y2 plus 9x minus 6x 3.
Okay. So whoever has that GCF.
I'll have 3x squared.
Would squared be the highest amount of x's? No.
3x 45x squared minus 4x.
that's mine. Okay. 5x would be that GCF. So then, who has the GCF of 49x to the 5th, y to the 3rd, plus 28xy to the 4th? What was that number, GCF?
7 and 1
Not to the 3rd. Or to the 4th. What's the lowest amount of x's these both have?
7x.
Yep. Is that yours? So whoever has that, you're up next. Go ahead and read it.
6x, 8 plus 10x, 6 times 2.
So whoever has that one. Because you're saying you have a 1. So not yet. This is 14, 15. What do these have in common? Any numbers? So they do have x's. How many x's do they have in common? 4. So if you have that, you are up next. Go ahead and do yours.
15x.
Go ahead. Continue to read it.
Third, y minus 35x. Squared, y squared, plus 20xy.
So whoever has that, you're up next.
What's the GCF of 9 to the 3rd power plus 30x?
That might actually be me. Yeah, okay. So 3x would be the GCF of that one. Who has the GCF of 72x to the 7th, y plus 24y? I believe that is the next answer. Yep.
Here is 60x to the 5th minus 24x to the 4th plus 36x to the 5th.
We have a GCF of 144
Whoever has that next one. Someone find the number GCF of that. 9. So if you have a 9, okay, go ahead and read it. Mm-hmm. Read the rest. Then whoever has that one, you're up next. That might be me, actually. X to the third, yeah. So x to the third is the GCF. Who has the GCF of 20x squared y minus 8xy squared? That might be me again, actually. I could have given X's out to you guys, but I would be forced to do 2. You barely want to do 1. So 4xy is this GCF. Who has the GCF of 30x to the 6 minus 75 x to the 4th minus 15x? This one I do not have. 5 works, but it's not the highest. It is 15x. Go ahead and read that out.
18x3 y2 plus 24x2 y2.
So whoever has that GCF, you are up next. It's between you 5. It's not me. Go ahead, Grace. Yep.
6x to the power 2 y to the power 2.
And then read the bottom.
7x minus 7.
Okay. That would be 7. So who has the GCF of xy squared minus xy? If you still have a card left, look at this. See if yours is this.
Is it 2-1?
Not 2y because you don't have any numbers. It's not yours. Not yours.
Actually,
Go ahead and read that.
who has the GCF of 27x power 3 minus 18x to the power 2 plus 45x?
You might. Read the bottom.
Who has the GCF of 32x minus 18?
So whoever that is. It's between just you two. Can you divide 32 by 6? 32 divided by 6? It is 2y. Do you want to read that? Go ahead and read that.
12x cubed plus 6x squared plus 6x.
And then your last. In which the GCF would be 2, which is what I have. So, good job. I did this just so you kind of remember your GCF stuff, because we're going to be jumping to something different today that's not really dealing with GCF. A little bit, but not really. So let's do these 3 warm-up problems just to kind of show you what we're going to be doing. So they gave us 2 sets of factors. They want us to multiply these out. And remember, we're using FOIL or distributing. So x times x would give us not 2x, x squared. And then x times -4, just x times -4, -4x. And then if we do the other 2, first outer, inner, 4 times x. What would that give us? 4x. And then +4 times -4. -16, big reverse. Right? Then we have like terms. The -4x and the 4x, if we combine them, what happens? They cancel, so just x squared minus 16 would be our final answer. All of these answers are going to be very similar. So let's do the next one. 5m times 5m, 25m squared, 5m times -1 would give us -5m, 1 times 5m would be the opposite, 1 times -1 would give us -1. So again, the middles cancel, and you're left with 25m squared minus 1. Who thinks they may know what the final answer for this might be without distributing? And if not, we can distribute. 2a times 2a. 4a squared. 2a times -3b. -6ab. Then the middle two, 3b times 2a. whether you put 6AB or 6BA does not matter. And then 3B times negative 3B. So then our final answer would be what?
4 squared minus 9.
Okay. So the things that we ended up with, these results, are called difference of squares because both terms are perfect squares. X squared is x times x, 16. Disregard the negative. It's 4 times 4, and we're subtracting. All of these are perfect squares, and we're subtracting. So we're going to be given those to find the factors. Right? Your rules. 1, you have to make sure that your terms are actual difference, perfect squares, and that you're subtracting. If either of those is not the case, you either need to factor out a GCF or it's prime. And then you're going to use this rule. If you see that this is a perfect square and this is a perfect square, and there's a subtraction in between them, then you're going to have 2 sets of factors. You have to think about what times what would give you the first term. So what times what would give you a squared?
1
A times a. So you would put that first in both sets of parentheses. Disregard the minus for a second. What times what would give you b squared? B times b. And then you're going to put a plus and a minus in between them. Does not matter which one you put first. And then if you wanted to check your work, you could distribute it back out to see does it work. Questions on the steps so far? This will go really fast because, once we get the hang of it, it'll start to go really fast. All right. Are a squared and 4 both perfect squares? Do they both have the same something multiplied? That was bad wording. Does a squared have something that can be multiplied by itself to get a squared? Something times something equals a squared. Is that true? Yes. What about 4? Is something times something equal 4 the same something? Yes. And we're subtracting. So you can write in your factors. What times what gives us a squared? A times a. What times what gives us 4? 2 times 2 plus minus. That is your answer. So as long as you know your perfect square numbers and then are able to find your variables, this should be easy for you. Questions on that one? Let's do the next one. N squared is like a squared, so I know that works. Is 64 a perfect square? Does it have something times something, the same something that will equal 64? Yes. 8, yes. So we would have 8 in the back of the parentheses. What times what will give us n squared? N times n. Put a plus, put a minus. Okay. 3 is a little different because the order has been switched. That doesn't matter. You're still doing the same thing. Is 81 a perfect square? Yes. So now, whatever order your original is, put that same order in your factors. So what times what will give you 81? 9 times 9. So then we have plus and minus x. Questions so far? Let's jump to 5. Be careful with this one, because here, k squared and 25 are both perfect squares, but this is adding. So we cannot do this one. This would be prime. So notice how this prime is different than our GCF prime. Because, yes, you can only take out a 1 of all of these things, but there are also not a difference of squares. That's the real reason this is prime. Okay. Now let's do some with numbers and variables together. 1 is a perfect square. Is 49 a perfect square? Yes. So we know 1 times 1 would give us 1. What times what would give us 49? 7. And then y times y would give us y squared. So you would put the y with the 7, put plus, put minus. What would our factors for 7 be? Think about what times what will give you 9, what times what will give you b squared, what times what will give you 100.
Times 3 gives you 9.
So then your factors would be 3b plus 10 and 3b minus 10. If at any point you want to double check, does this work, especially when you get to bigger numbers, off to the side, you could multiply them. You don't have to do this, but if you want to, be my guess. So we have 9b squared minus 30b plus 30b minus 100. The middles would cancel, so we get 9b squared minus 100. So we do get the same thing. So if ever you want to check yourself, use that method to check yourself. What would the factors of 8 be? And 449. So plus 7 and the other 5x minus 2. Let's jump to 10. Because now we have multiple variables, still doing the same thing. What would your two factors be? So when you read off your factors, tell me all of this and then all of this, or one or the other. So x 9 y. And then the other one? Minus 9. Right, what about 11? Doesn't matter whether you put plus or minus first. 2h plus 5g, and then the other one? Okay. Questions about this process so far? We're going to do some harder ones. Okay, on the back. Let's start with 13. Same process. What would your factors be? And correct. Now with 14, notice that there is now something to the fourth power. Anytime you see exponents that are even, this will still work. sometimes you'll get something where you have to keep factoring. So I always have difficulty making up this example. But let's say you started off with something here that whatever this was, you were able to divide again. Like 9 is a perfect square. I'm making this up. Write this off to the side. Okay. What is that? 500. Someone do this really fast. 25 squared or 25 times 25. I don't even know what that is.
625.
Okay. So let's say this says 625 instead of 25. 25 times 25 gives us that. So we'd end up with this. Nine and 25 are both perfect squares again. We would not do anything with the plus, but with the minus we would do it again. So instead of 2 factors, we'd have 3. So this first one would stay the same. The second one would become 3n minus 5 and 3n plus 5. So if you still have perfect squares and everything in there is a perfect square, keep going. That doesn't happen often, but sometimes it does happen. I think 15 was a typo. Yeah. I think 15 was a typo because 5 is not a perfect square, even though everything else is. So because that one thing is not a perfect square, we can't do anything with this. This would be prime. Maybe it was supposed to say 25. I don't know. Let's do 19. So the same thing you did for the 4, you're really just cutting it in half, dividing by 2. So what would your factors of this be? 11 r to the third plus 1, and then right. Before we do some examples with GCF, are there any that we skipped over up to 20 that we want to see, go back over, have questions about? Right. So one of the Khan Academies you'll see is based on just difference of squares, different formatting, maybe it's r to the 4th, r to the 6th, things like that. Then the other one will be things like this, where you have a GCF. So, if you have 2 terms, you can only do one of 2 things. Either take a GCF and see does it factor anymore, or do difference of squares. I might call it dose instead. So you can only do one of those 2 things if you have 2 terms. I would always check with GCF first. So here, do these have anything in common? Could you divide anything out of both of those? 2. So if we do that, what's left? So n squared minus 36. Now looking at the inside, we can't take anything else out GCF-wise, but are those perfect squares? Yes. So then we can do what we've been doing and find our 2 factors, which would be what? And again, if you put plus first, it does not matter. Right? So these are like taking 2 of the things we've learned and putting them together. Let's do 24. Yes, we can take out a 5. Anything else?
I get Thomas.
Yes. Anything else they have in common? 2. So if we take out 5 cubed, what's left? Q squared, and we're missing a number here.
4.
Not 4, 9. 9q squared, not 2 4. And then the second one? Not 5, because we divided by 5. That one, I think, is where the 4 came from, yes. Okay. Are the insides perfect squares? Yes. So then we can keep going. What would those factors be? 3q plus 2 and 3q minus 2. So don't forget your variables in those. Questions so far? We're just going to do a few more of these, and then any you guys want to see, and then we'll have them like this. Alright, so let's do 26. You might notice that first 136 are both perfect squares, but are our variable terms perfect squares? No, because they're both odd. One's 1 and one's 3. So we definitely have to take out a GCF. So because we're taking out a GCF, we can't just take out B. We have to take out whatever they have in common. So what number do they have in common? 2 works, but it's not the highest. And remember, you can start at a lower number and then factor it out later. When you're practicing, this would be a good time to have Desmos up on the side and do that, or you can be listing out your factors, either or. Give me some factors of 100. Give me a 2, 1 and 100, but that wouldn't really change anything. 10 and 10. There are some others. 4 and 25. 436, factors of 36. 1 and 36. 4 and 9. Couple more. And I think there's one more. So you got 1, you got 2, what about 3? Okay, so our highest GCF? 4. So 4 and how many B's? 1. We take out 4B, what's left? 25B squared minus 9. Can't take out anything else GCF-wise, but are those a perfect square? Yes. So what would those two new factors be? 5, we're missing something? 5, just b, minus 3, and 5b plus 3. Alright, let's do 27, 28, and then any others you guys want to see. For 27, what could we take out, or is there anything that they have in common? Let's start there. Say that again. I think so. I keep forgetting my calculator at home. 80 and 1.5. Yes, it is 5. Do we have any n's in common? N squared. If we divide that out, what's left?
16.
N squared minus and then those are perfect squares. What would our two new factors be? Minus 5 or plus 5. And then for n is the opposite. And then 28, I said. What is the GCF there? 8. As we said, 4 would work, but it's not the highest. So 8. Any variables? Yep. If we take that out, what's left? X squared minus any y's left? Y squared. So then what would those factors be? X minus y, and then x plus 2. Are there any others in that section we want to see, go over, have questions about? Yes. So let's think about factors of 18, factors of 50. Is there anything they have in common? So if we divide out 2, what's left? X squared minus and then we could factor that using difference of squares. Just x. And then the other. Any others we want to see, go over, have questions about? If you were paying attention, you could knock out the 2 Khan Academies that are due on Friday in 10 minutes max. Okay, so do those. If you did not do the one from last week, also do that. Email me so I can update that grade. Work on those things. If you need more practice, go back to these notes. If you have questions on any of that, let me know.